in order to graph a polynomial, we must first factor it. Now, the way to factor a polynomial like this is to use the rational root theorem. Over here on the right is the result of using it. So if you remember, the factors of this term over the factors of this term will give you the possible factors. So using the factor theorem, any one of these values put into here, if this results in 0, then we know we have a factor. Now, looking at this particular polynomial, it is a bit of a guessing game, but you can probably infer that the number has to be negative, because if it's a positive number, it's obviously not going to equal 0. So I'm going to try to input a negative number, such as negative 2. As you can see, negative 2 results in 0, so we know negative 2 is a factor, so we'll use that factor in synthetic division. So taking the original values from above and putting them in. Simply bring this value down, multiply it with the factor, and then you just add and repeat. Remember, when you add a negative, it's basically just like subtracting. So the remainder is 0, so we know that's good to go. Let's go ahead and try the same factor again for the new set of values that we have figured out. Once again, bring it down and just multiply it over. Add it down, multiply over, and repeat. And we once again get a remainder of 0. So this, 4x plus 3. And bringing these two terms down would give you x plus 2, because remember, the 2 switches to negative, squared. So that is your polynomial that we can now graph. Now, before we start graphing it, let's find the y-intercept. The y-intercept is basically just whenever x equals 0, so input in a 0 for x in this polynomial will give you the y-intercept. So the y-intercept is 12. Important to make note of that. So now let's just begin to plot these points. The first one, the y-intercept, we just figured out. Let's just plot it right away. To find the other 2 points, take the factored polynomial that we just factored and isolate x in 2 different scenarios. So for each of these equations, solve for x. Solving for x here will result in negative 3 over 4. So let's just plot that point. Solving for x here will result in negative 2. Let's plot that point as well. It is important to note that since there is a squared on this equation, that means the multiplicity of this point is 2. The graph will then intersect that point twice. So, now that we have the points plotted, how exactly do we know what the shape of the graph is? That's when we turn to the original non-factored polynomial, which is right here. As you can see, it is 4x cubed, which we remember. Now, the important thing to look at here is the highest exponent of x. In this polynomial, it is 3. Now, a polynomial with an exponent of 3 leading the way will have a shape in either 2 different cases, either left down, right up, or left up, right down, all dependent on this value. But since this value is greater than 0, we know it's a left down, right up graph. So now we can begin to plot these points. As I mentioned earlier, because the multiplicity of this point, negative 2, is 2, the graph will intersect it twice, so it basically just bounces off of that point. We just have to connect the dots at this point. Now, along this side, I scaled it up 2 times for each one, because a 12 would be at the top, it would be too close, it would be uncomfortable, and it's important to note, if you're ever going to scale it up, you have to do it properly. You have to label the points, and you have to respect the scale that you're using. So each of these points goes up by 2, and it shows properly. And yes, that is it. That is how you graph a polynomial.